Okay, so I'll just give a brief overview of smart contract security and some of the cool things that are in that realm. Okay, so yeah, so on smart contract security, it's one of the newer field because well, smart contract didn't exist before, and there is a lot of problem with smart contracts that are unlike typical code because of the way the language is written. It's deterministic and so on and so forth, right? And the way it's executed is quite different from typical machine codes. So then there is also like new type of problem, right? So I think to understand it, this article talks about formal verification of smart contract, and it's interesting in the way that it talks about mathematical concept when you are considering like something is secure, right? So number one, you want to say that it does what it wants, it does what it does, right? And that's correctness, right? And unambiguous in description of tasks, right? And then they talk about static and dynamic analysis, and then like this terminology you come to be quite familiar with, like RJ and myself who went to a course, and basically the entire freaking course is just on horse logic, right? On the triples of precondition, instructions, and then post condition. So talking about the correctness of a program, right? Especially in this class of like code and whatnot, you can actually use mathematical proof to prove certain things, right? So when you want to prove correctness, right, you cannot just say that this smart contract is correct or this smart contract is secure or what, right? You want to prove certain properties, like let's say this this smart contract cannot have this property true and that property also true, right? So these are some properties. Basically, they are called invariants, right? Some things that cannot happen, right? So in terms of like different types of way you can analyze smart contract, there are many ways. Typically, you just look at high level and low level, right? High level are basically the things like the code that you already write, so Solidity or Viper, right? So in the way you are using typically like static analysis, so it's kind of like an engine that looks at your code and it's like, oh, it looks right, it doesn't look like there's a problem, right? But then the problem is that there exists problems with, let's say, compilation, or let's say with the basically the different versions of, let's say, the SOC compiler, right? That results in different bytecodes given the same, high-level language, which is your Solidity file, right? So there is also a need for you to say, okay, I need to check that my bytecodes actually cannot represent a state that, or cannot enter into an invalid state, right? So these are typically what people look at. If you're just looking at the code, then you're just really just looking at high-level languages, right? Um, and also do note that if you're not writing like smart contracts, right, it is not a must that you must write it in Solidity. You can write it in pure bytecode if you so wish to. Um, yeah, that's a challenge. You can go ahead and figure it out yourself. Okay, so that's pretty much like the overview of the approach to smart contract analysis, right? So if you want to look at some of the resources, right, there's a big list of resources that is maintained by Crytek, and this is actually the company Trail of Bits, um, which is one of the vendor I keep saying like it's good, it's good. So they actually produce some of the best like open source tools and articles regarding like smart contract analysis, right? So these are a lot of resources, and of which I'd like to highlight a few right today. So first one is actually this SWC registry. So it's called Smart Contract Weakness Classifications and Test Case. So they have a lot of let's say weaknesses. So let's say unencrypted private data on chain, right? And then they will tell you what are some of the samples, right? So if you have like those re-entrancy attack and stuff like that, you can also find them here. So this is a good way for you to learn what are some of the common vulnerabilities. So it's like the OWASP standard, like OWASP 10, that kind of thing. There's also like the equivalents in the Ethereum space, like like the top 10 vulnerabilities, that kind of thing. But this is kind of like a more complete registry. Some of the newer ones are quite interesting. Like you can see there are cases like, let's say if you are missing 2 characters in your address, you can hack something, that kind of thing. Yeah, so there's a few problems with that, right? So this is one of the resources you want to look at. Okay. Okay. So today I'll just talk about static analysis and this 3 class of things, like, and show you the tools, right? So if you so you are familiar with static analysis, right? So basically you look at the code and then like, what's right and what's wrong with it. So there's this also Critic, right? I'm going to show you 3 tools. Number 1 is Slither. So Slither is static analyzer for solidity. Etchner is for fuzzing, and then there is Manticore, which is for symbolic execution, right? I'll explain the rest later. So Slither is the easiest to explain, right? Because static analysis, run it, nothing come out as high, good. That's all lame shit, right? That all your vendors does, right? So to run it is quite simple. So I'm going to run it against like our repo. So I'm going to go to, this is our document store, right? All right. So the first thing I'll do is basically the default analyzer. So, right. So it does the compilation, and then like it tells you, oh, there's a few detector that detected something. Number 1, it's upgradable, and there is a variable shadowing, right? So basically, you see this variable called gap, right? That's a problem because there is multiple gap. Yeah, flatten, or upgradable. Can you see that there is a 50 bytes, 50 times 32 bytes gap there, and then there's like 49 times 32 bytes gap here. So now the question is, what happens here? Are there going to be 1 gap or 2 gap, right? Take a guess. Anyone? So when I look into the smart contract, is there going to be one set of this, or are there going to be 2 sets of this?
2.
2? Okay. Why? Okay, never mind. Forget it. Actually, I got it wrong too. So I thought it's 1, right? And the right answer is actually 2. I'll show you like how to look at that later. So basically, this one is a good way to help you detect things that you are likely gonna miss, right? So this basically is mostly shadowing, but basically, if let's say there's a chance for you to re-enter the smart contract, for instance, like I call another one and then the other one call this one, and then it calls again, that sort of shit that will basically destroy the DAO, then it will also appear here. So there's multiple detectors that is in the Critic language. Detector. So these are the detectors. So it's capable of like detecting, like, let's say incorrect shifts, contract name review, so shadowing states, suicidal, that kind of thing. So let's say I have a public function that allows anyone to call the contract and suicide, it will just flag out, right? So even like random number generation. So if let's say you're doing a gambling ad, you'll be able to see this as well. Okay. So the next thing is a function summary. So this gives you the next few commands I'm going to show you gives you a good like overview of like what your contract is like. Okay. So if you look at upgradable document store, straight away you can have an overview of like oh, these are all the functions that is available on this smart contract, right? And very important, their visibility, right? And then like it also tells you what exactly does it read or write. This means that if let's say I see let's say I'm hacking a let's say DeFi smart contract, and I'm interested to see if it's able to change the balance of my own account. Then basically I'm looking for all the functions that are rights to balance somehow, right? And I will be able to narrow down the focus to those that are basically of interest to me. So this quickly helped me narrow down those things that are of interest to me. Okay. And then like it also shows you the internal core and external core, that kind of thing. So external core are also important because if let's say you call to external contract, right, you want to make sure that either those contracts are verified or what, right? So those are interesting as well as these modifiers. So next up, I will run this. Basically, this gives you the function signature itself. So when you look at like let's say Etherscan, and then they tell you there's a function signature that was called, let's say this one, you have to see the name is actually here, right? This allows you to give allows you a low level control of let's say you want to do a raw bytecode, you can just write this immediately. Other than that, this is just the human summary. There are a few interesting, yeah, this one. So remember just now my question was like, given the state storage, how many, how many slots are there, that kind of thing. So you can immediately print out the slots, right? So recall that, in smart contract, there's like the public variables and the private variables, right? But then we also know, I hope, that all of you know that there's no such thing as a private variable on the blockchain because it is public, at least to the human. Private just deny another smart contract from reading into it, right? So let's say I have a variable somewhere, let's say here, that says, let's say uin256 private password, or you're screwed, right? So this password, although it's private to other smart contract, Raymond can just look up the which slot it was in, and then I will just read it off from there, and I would know the password, right? So this one will tell you the storage mapping. So another thing why this is important is that we talk about this a lot, upgradable, right? The problem with upgradable is that if your next contract, that the current contract upgrades to does not have a compatible storage layout, you are going to just screw yourself up, right? So imagine this: if let's say version 1 of my document store has the name in slot number 1, right, and version 2 of it simply just sorts around, let's say, the name, right? I do this, right? Instead of like this, I do this, right? Let's say, okay, so let's say version 1 looks like that, version 2 looks like that. You're screwed, right? Basically, the second version of it is going to read the version as the name and then the name as the version, right? So this is very, very, very important whenever you want to do upgradable contracts, right? So just, yeah, don't think like contract upgrading is easy. Like this is one of the biggest problems. You guys might find out in the future. Other than that, okay, so this is also on variables and authentications, right? For instance, what kind of method and what kind of thing can access what variable, right? So basically you want to see like what are the things that, if I want to revoke, I only write to document revoke. So instantly I can tell you that, okay, if I revoke a function, if I revoke a document, I actually don't edit the document issued data structure at all, right? So this is a good way for you to see what things are being written. So if you look at this, generally you can tell if like a function is going to fuck it up or not. Yeah. So this is just static analysis, right? And I think I'll cover like dynamic analysis or symbolic execution next time. Yeah. So I can take questions now. Anyway.
Do you find anything wrong?
From the static analysis, no. dynamic analysis also no lah. But yeah, it's actually quite complex. Now that I look at this, right, honestly, I'm having second thoughts about having upgradable smart contracts. Because the I mean, you look at the storage space, right? It is actually very, very, very complex. And if you have the next version, you really got to make sure like all these things are the same. And the problem with that is that all you need to do to fuck it up, right, is like basically, let's say this is your upgradable smart contract, right? You take this, then you put here, bam, fucked up. Yeah.
Yeah, the maintenance burden is quite high on the next guy.
Correct. So to make sure that something is compatible with the last version, it's quite dangerous, lah, right? Because if you were to do this, you'll see that the storage mapping would have changed.
I guess there's a silver lining in that if it's upgradable, you can revert to.
Let me see. Let me see. Yeah, I think it changed. You can upgrade it provided if no one called the contract already. You see that the slots are all different now, right? All because I switched these two around, then you like screwed. Yeah, so
that's scary.
Yeah, it is scary. Yeah, and these are not the things that when you do code review you can see immediately. It's like unless you run this tool, you won't notice that actually the whole freaking storage array has changed. Yeah.
Okay, we need to hire a blockchain expert.
So next time someone asks about upgradable, or you can show them this. It's quite scary, like, yeah. No, big change just because I saw this. Any other questions? Okay, that's it then.